seventh graders, let's go ahead and knock this homework out really quick. I've got all the odd ones as usual. It says here, write the word sentence as an inequality. A number P is greater than 5. Well, that's pretty easy. I'm simply going to make, I'm not sure why it's not letting me use the marker here. Something seems to be wrong. Oh, there we go. A number P is greater than 5. That's how I would write that. All right, let's go to the next one. The sum of a number and n, well, that means some number, the sum of a number n, so that's the number, right? And 2/3, so we're going to add n to 2/3. It's the sum, so it's an addition problem. Is no less than 5 1/3. So over here we're going to have 5 1/3. So that means it could equal 5 1/3, but it could be no less than. So it could be bigger than or equal to 5 1/3. All right, now we have number 5 for me. I got W over 3 is equal to -9. Remember what we talked about? This is a one-step equation. So since W is being divided by 3, the only way I can go ahead and undo that is to multiply W to 3. So I'm going to multiply this to 3 over 1. And that's going to equal -9. Remember, whatever I multiply to one side, I multiply to the other. So I'm going to have to multiply this one to 3 over 1 as well. And now I've got, well, the 3's cancel out because this is 3 divided by 3 is 1, 3 divided by 3 is 1. 1 times W is W. And now I have -9 times 3 over 1. Well, -9 times 3, that's a negative times a positive. That'll give me a negative. And 9 times 3 is 27. All right, let's go to number 7. It says 60 equals 3 over 4 h. Well, I know that 3 over 4 is being multiplied to h, and I can go ahead and multiply to the opposite, 4 over 3, in order to get rid of it. Because now I have 4 on the bottom, 4 on the top. 4 divided by 4 is 1. 4 divided by 4 is 1. And 3 on the top and 3 on the bottom. 3 divided by 3 is 1. 3 divided by 3 is 1. But whatever I multiply to one side, I have to multiply to the other. H is going to come down here all by itself now. Now I have to take 60 and multiply it to 4 over 3. That is an ugly 4 over 3, so I'm going to rewrite it just so I don't confuse anybody. Much better. All right, so how would I do this one? I see that 3 and 60 are both divisible by 3. 3 divided by 3 is 1. And 60 divided by 3 is 20. And now I have 20 times 4, and that's going to be 80. So H has to equal 80. All right, let's go down to number 9. This says, write an inequality that compares the given numbers. Does the inequality remain true when you add 2 to each side to justify your answer? Let's just use any inequality. I could say -1. Well, that's going to be less than 4, right? And now what happens if does the inequality remain 2 if I add 2 to both sides? So this would be, let's see, -1 plus 2. is it going to be less than 4 plus 2? Well, negative 1 plus 2 is 1, and 4 plus 2 is 6, and 1 is less than 6. So yes, the inequality remains true. All right, let's go ahead and do number 11 now. Number 11 says negative 4 and negative 1. Well, I know that negative 4 is less than negative 1, because on the number line, it's more to my left. So if I add 2, negative 4 plus 2, will it still be less than negative 1 plus 2? Well, negative 4 plus 2 will give me negative 2. And 2 minus 1, that's just 1. So yes, negative 2 is less than 1. So once again, I can say that, I'm just going to copy this. The inequality remains true. Oh, wow, I did not spell true correctly. You guys must be getting a good kick out of that. All right, so I'm going to put my T here for both of these and make it true. Here. All right, let's do number 13 now. Solve the inequality, graph the solution. Okay, so I'm going to solve this inequality. The only way to get A by itself is to move my number to the other side of the inequality, just like an equation. So I'm going to add 2 to get rid of my negative 2. Whatever I add to one side, I add to the other. When I do this, A comes down by itself. The inequality symbol comes this direction. 2 minus 2 is 0. I'm not going to add that, but 4 plus 2 is 6. And now A is greater than 6. So if I make a graph, their idea of a graph is a number line here. And I put 6 here. Since it doesn't have a line underneath, this will be an open circle. Since A is bigger, I'll shade in all of the spots or all of the numbers that are bigger than 6. All right, let's go on to number 15. This time we've got 8 plus k is less than or equal to negative 3. Again, I want to get k by itself, so I'm going to subtract 8 from it. I do this because my like terms, right, these are both numbers. 8 and negative 3 are numbers that I can combine. I cannot combine k with anything over here, so I have to move the 8, which means I'm going to subtract 8 from this side as well, just like I would an equation. K comes down, so does my inequality. And negative 3 and negative 8 make negative 11. I know this because when my signs are the same, I find the sum, and 8 plus 3 is 11. When my signs are the same, I also keep the same sign. This is like me borrowing $3 from you, and then I borrow 8 more. I owe you 11. Let's go to number 17. Oh, wait, I still have to make the graph over here. I almost forgot that. Always remember, we have to go ahead and complete our work. Do all the things that are said in the problem. So this would be a negative 11 down here. I know that k is less than or equal to, which means I'm going to shade in a dot. I will not just leave a circle, because it can include a negative 11. Since k can be smaller, I'm going to shade in all the lines, or all the numbers, excuse me, that are bigger than 11. All right, let's go to number 17. I need to get rid of this negative 4 that's within. I'm going to add 4 to it. Whatever I add to one side, I add to the other. n comes down. So did my inequality symbol. I'm not going to put 4 minus 4 is 0. I never put plus 0. That's a waste of time. And 5 plus 4 is 9. So n is less than 9. So let's get another line here. Let's see here. One of these have lines that go both ways, so I'm just going to take that one. Okay. And I'm going to make 9 right here. Since this 9 is less than, or n is less than the number, I'm going to put a circle here. It won't be 9, but it will be all the numbers that are less than 9. All right, let's go to number 19. This time we got p plus 1 over 4 is greater than or equal to 2. Again, I'm going to subtract 1 over 4 to get p by itself, which means I'm going to subtract 1 over 4 over here. Now, p is alone, and 1/4 minus 1/4 is 0. My inequality symbol comes down, greater than or equal to. Now I have to take 2 and minus 1/4 from it. That's pretty easy. That's going to leave me 1 and 3/4. In case you didn't see how that works, I could take 2, I can borrow 1 from 2 to turn it to 1 and 4 over 4. I'm going to make the 1 that I borrowed over here, I'm going to make a 1 in the form of 4 divided by 4, because 4 divided by 4 is 1. Now I have a common denominator. 4 minus 1 is 3. All right, so now I've got to make my graph again. I'll show this as 1 and 3/4. And since p is greater than or equal to it, this will make a solid dot. And I was shading all the numbers that are bigger. Oh, that came out really ugly, but still effective. All right, let's go to number 21. This time I got negative 4.7 with z. Z is being subtracted by 4.7. I'm going to add 4.7 to get rid of this negative 4.7. Whatever I add to one side, I have to add to the other side. So I'm going to add 4.7 over here. Well, z comes down because I didn't do anything to that. My inequality symbol comes down. I know 4.7 minus 4.7 is 0. But over here, I got 4.7 combining with negative 1.6. When my signs are different, I take the big number minus the small number. And that's going to give me 3.1. And since the big number is positive, it's a positive 3.1. So z is greater than or equal to 3.1. I'm going to go ahead and get my line out here again. Put 3.1 under it. And since it's greater than or equal to, since it has that line there, I'm going to shade in my dot. And since it's bigger than all the numbers that are bigger than 3.1. All right, number 23 is next. It says I've got 8 over 5, and it's going to be greater than s plus 12 over 5. Well, once again, I'm going to go ahead and get s by itself. I'm going to subtract 12 over 5. And whatever I subtract from one side, I subtract from the other. All right, now I've got 12 over 5 minus 12 over 5. That's 0. That leaves me s on this side. And the less than sign, or actually there's the greater than sign. And now I see that I've got negative 12 over 5 combining with 8 over 5. Well, my signs are different. Because I have common denominators, I'm just going to add my numerator, which is the numbers on top. Negative 12 plus 8 is going to be 12 minus 8, which is 4. And then I keep the sign of the bigger number, which is negative. So negative 4. So now I can make my graph again. I'm going to put negative 4 underneath because it is negative 4 is bigger than s. It will not include 4. That would be an open circle. Remember, negative 4 is bigger than s, so s is smaller than negative 4. That means all the numbers that are smaller than negative 4. All right, number 25 is next. R plus 0.2 is less than negative 0.7. Well, I need to get r by itself, so I'm going to subtract 0.2. Whatever I subtract from one side, subtract from the other. I know that 0.2 minus 0.2 is 0, so that leaves me r over here. My sign comes down, and then I have negative 0.7 minus 0.2. When my signs are the same, I find the sum. So 7 and 2 make 9. That's the big 0.9. And now I make my graph. I'm going to put 0.9 down because that's the number I found. And then since r is smaller than 0.9, I'll make an open circle so it doesn't include 0.9 and shade in all the numbers that are smaller. All right, let's go ahead and do number 27. Your friend solves the inequality and graphs the solution. Is your friend correct? Explain the reasoning. Well, he says to get rid of a negative 7, I'm going to have to add 7. That's true. If I add 7 to one side, he says that I'm going to add it to the other. That's true. It says here that I've got negative 2 plus 7, and that's the same as 7 minus 2. That equals 5. That's also correct. So they're saying x is bigger than 5. And over here, they have a graph with 5 here and all of the numbers that are bigger than 5. Here's one problem, though. They shaded in the dot, and this means that it is not equal to 5. What they should have done is had a graph that looked like this. You should have had 5, and then you should have had an open circle, not a closed dot, and then showed all the numbers that were bigger than 5. Okay. Um, so says explain your reasoning, we would say the graph should have an open dot or open circle instead of a dot. All right? All right, let's go to number 29 next. All right, let's move on down. It says, a large airboat can hold 30 passengers. There's no way 30 people are going to fit on here, but fine. 17 passengers board the airboat. Okay, so it can't hold, it can hold up to 30. Okay, so that tells me that 30 is going to be on one side, and I can use the symbol less than or equal to. It could equal 30 or be less than 30. It cannot be more than 30. It says 7 passengers board the airboat. So that means the 7 people are there, and I can add this to some number, since it's not telling me the other number, and it has to be less than or equal to 30. Write and solve an inequality that represents the additional number of passengers that can board the airboat. All right, there's an inequality. Now I've got to solve it. So I would subtract 7 from this side to get n by itself, which means I subtract 7 from this side. I'm sorry, this is 17. Wow. All right, so that's 17 on both sides. N is now by itself. The inequality symbol comes down. And 30 minus 17 is 13. So n has to be less than or equal to 13. Can 14 passengers board the airboat? Well, we just said only 13 could. So no, only 13 or less passengers can fit on the airboat. Okay. Let's go to number 31 now. 31 says, the base is greater than the height. What are we doing here? I'm going to have to find out what the instructions are. Hold on a second. All right, I found the instruction. It says, find the possible values of x. Okay, so let's see, make that more readable. All right, find the possible values of x. We have number 31. The base is greater than the height. So we need to find out what x is. We have x plus 3 inches here and 8 inches up. I happen to know that the formula for a parallelogram, which is what this is going to be base times height. Not that it should matter here. Find the possible values for this. If I did this, I realized that, let's see, I've got 8 inches here. And let's see, the base is greater than the height. So this has to be bigger than this. So we can erase this all together. That didn't even matter. So the base is x plus 3. It has to be greater than, not greater than or equal to, but greater than 8. Now it wants us to find the possible values of x. So I'm going to have to solve this. I'll subtract 3 so I can get x by itself. X comes down, 3 minus 3 is 0. And x is going to be 8 minus 3, which is, x has to be bigger than 5. All right? If I was to graph this, and I don't think they're asking us to graph it, but if I did, it would look like this. x is bigger than 5, so I put an open circle and I shade in all of the numbers that are bigger than 5. All right, that was number 31. Let's go to number 33. The inequality d plus s is greater than -3 is equivalent to d is greater than -7. What is the value of s? Okay, well, let's see. D is greater than -7, right? We know this is bigger than -7, so it can be -6 or anything high, right? Let's just put a number line so we get a visual here. Remember, D, we're just going to put it over here, is -7, right? So we know that D is going to be bigger than -7. So does not include D, but it's going to be a number bigger than -7, right? And we know in this inequality, D plus S is going to be bigger than -3. So if I put -3 over here, remember that D plus S is bigger than -3, okay? So let's examine that. If I know that D has to be bigger than -7, which includes all these numbers, and I know that D plus S has to be bigger than -3, the value of S has to be what? Well, we know it has to be bigger than, let's just say if I looked at -6, because -6 and -7 would have to be what? Because let's say if this was if this was -6 and I added it to another -6, that's going to go ahead and be -12, right? So since there's between -7 and -3, there's 4 there. I'm thinking the answer is probably going to be 4. Let's go ahead and solve this mathematically, though, and make sure we got the right answer. First of all, let's solve this one here. We got D plus S is greater than -3. Remember, we have D over here, so we're going to try to find out what D is. So I'm going to start over here by minusing S. Whatever I subtract from one side, I subtract from the other side. And that means that D has to be greater than -3 minus S. Notice I can't combine them, but I can make a formula here for it, right? Now I'm going to replace D with the number -3, because we're trying to find out what S is. -3 minus S is greater than, let's see here, -7. Remember, this is an S, not a 5. All right. So now I'm going to have to combine my like terms. So I'm going to add 4 to this side, which means I'll add, oh, excuse me, I'll add 3 to this side. Sorry. Which means I'm going to add 3 to this side. And that's going to give me a -4 over here, an inequality sign, and a negative S. Now remember, I'm not trying to find out what negative S is. I want to find out the value of S. So in front of every letter, remember there's a number 1, right? So that means I can divide -1 away. Whatever I divide from one side, I divide from the other. Now S is by itself. And 4 negative divided by negative is a positive, and 4 divided by 1 is 4. Here's the problem. Whenever I multiply or divide by a negative number, I have to turn my symbol in the other direction. That's a rule. So S will be less than 4, but we're going to put all this because remember we're trying to find the value. We're going to go ahead and I think what we should be doing is putting an equal sign here because we're trying to find S. That means S is going to equal 4. That makes sense, right? Because 4 is bigger than -7, right? And, oh, sorry, this is D. We found out what S was. Let's see. S, if I took -3 and this was a 4, I would have to say that negative, let's see, I'm trying to figure out how to do this backwards to check it. I'm pretty sure that if I took S over here, made it a 4, when I combined it over here, I'd have a -7, right? Yes. So that would go ahead and tell me this number is bigger than -7. So I would have to get a number bigger than -7. If this number is 4, right? Then whatever number I get over here has to be bigger than 7, because when I subtract 4 from this side to get D by itself, I have to subtract 4 from this side. And you see that -4, -3 make -7. My D is by itself. But remember, D is going to have to be bigger than -7 for this to be true. So yes, S is equal to 4. All right, let's go ahead and go to number 35. It says if items plugged into a circuit use more than 2,400 watts of electricity, the circuit overloads. A portable heater that uses 1,050 watts of electricity is plugged into the circuit. Okay. Remember, the items plugged in the circuit, if they do more than 2,400, it's going to blow. It's going to overload. A portable heater that uses 1,050, and it's not listed over here, is plugged into the circuit. So remember, we cannot, it says use more than. So in other words, it can equal it, right? So we know that it can equal, it has to be less than or equal to 2,400. Okay. It says we got 1,050 that we plugged into it. Okay, find the additional number of watts you can plug into it. So some number plus 1,050 has to be less than or equal to 2,400. I'm going to minus 1,050 from this side to get n by itself, which means I have to minus 1,050 from this side. When I do this, I get a 0. I'll have to borrow 1 here, making this a 3. And 10 minus 5 is 5. 3 minus 0 is 3. And 2 minus 1 is 1. So n has to be less than or equal to 1,350. It says find the additional number of watts. Well, without overloading it, I can get a number has to be less than 1,350 watts. In addition to the possible heater, remember this was the heater that we plugged in, right? What two other items on the table could you plug in at the same time without overloading? So the sum of these things can't be more than 1,350. All right. I know if I add 200 and 1,200, that's going to be 1,400, and that's more. Can't do that. I have 1,100. I can add that to 200 to get 1,300. So the aquarium and the vacuum cleaner will work. The aquarium and the vacuum cleaner. All right. Let's see what else here. Oh, I'm sorry. This is vacuum cleaner. Okay. That's one set. Another set could be the television and the aquarium. The aquarium. Let's see. And the television. Okay. Are there any other combinations? Oh, the vacuum cleaner and the television could also go together because that would just be 1,250, right? So I can put as well the vacuum cleaner and the, let's see, television. And if we look carefully, since we can get up to that, right? It says we can't go more than it, but we can't get up to it. We could even take the hair dryer and the television. It will only be 1,350. So the hair dryer and the vacuum cleaner. Okay. Let's see. The vacuum cleaner, the hair dryer. Yep, that adds up to exactly the amount. The vacuum cleaner, the television, the aquarium, and the television. Okay. And of course, the aquarium and the vacuum cleaner. All those will be numbers that are less than 1,350. All right. Well, number 36 is for you to do, which means I don't have any more to do. We will grade these in class when you come in. Good luck with the rest of them, and have a good